Did you know that RouterOS has its own scripting language? Most things that you can imagine automating on your router can be scripted. Little niche features that would be nice to have could just be added by yourself, and you don't need a computer science degree. If you have a basic understanding of how scripts work, then you can script in RouterOS. So how does RouterOS scripting work? Similar to popular languages like Bash and Python, you can script directly into the terminal, which is convenient when you are trying things out and checking if a particular command would work, as well as when you want to execute multiple commands in order. But whenever you come up with something worthwhile, of course you want to store it as a script, so that you can execute it whenever you want to. In RouterOS, instead of creating script files, you store your scripts in the System Script section. This just helps with permissions and also keeps things organized. Let's just go ahead and add a little script so that I can show you the very basic principles. All that is needed for now is a name for the script. As you can see, a bunch of other parameters got generated, but we don't have to understand them. We can just begin editing our source. Now that puts us in the built-in script editor. Nothing fancy, just a text editor that will highlight the syntax. Here we can enter any RouterOS commands just like we would in the terminal. So the most basic script could consist of multiple lines of configuration. But the possibilities are pretty broad, to say the least. You are mainly limited by your imagination here, as we have all the fundamental building blocks available. Starting with variables. There are 11 data types that you can use, but you don't have to specifically declare them beforehand. They are automatically recognized when you assign value to the variable. What we have to specifically declare, however, is the scope, as we have two options, local and global. To create a local variable, type column symbol followed by the word local, a space, and the name of the variable. You can leave it like that or add a value after that. A number will declare it as an integer. Similarly, characters would create a string, and typing true or false would result in a boolean. The global scope variables are declared just the same. Next, let's print them using the put command. As with all RouterOS commands, it has to start with the column symbol, and to get the value of a particular variable, we have to use the dollar symbol. Without a dollar, put would simply output the name of the variable as a string. Now we can save and close the script using Ctrl+O, and then we can run it. As you can see, both variables got printed the same. But the difference here is that after running the script, the local variable got removed, but the global is still stored in the RAM. You can verify that in the environment subsection. If I issue a put command, it still returns the value. The global variable could be handy when you are building your own little ecosystem of scripts, but needlessly using it is not a good practice and should be avoided. To clear the variable from the RAM, we can reboot the device or issue a remove command. The local variable is the safe option we want to use whenever possible. The only thing you have to keep in mind is the limited scope. If I put curly brackets around a local variable like this, anything calling it outside those brackets will fail. So this put command would not work anymore. RouterOS scripting supports all the typical arithmetic operators, so I could multiply this number by 2, for example. The set command lets you change the value of the variable. Just make sure you place your mathematical operation in regular brackets. Multiplication works fine, but arithmetic operators are not the only ones available. For example, there is no power operator, and if you want to use the typical symbol, it will actually perform a bitwise XOR operation. This script now returns 121 because the bit resembling 2 got flipped down on that variable. All sorts of quirky things can be done. I won't cover all the operators now, you can look them up on the help page. If I want to actually square this variable, I have to simply multiply it with itself. Next, I could do a conditional statement. After the if, you could do the condition in brackets and then you type do equals and place any actions inside curly brackets. These can be multi-line actions. I will leave it as a one-liner and run it. Works just how it should. Finally, this wouldn't be scripting if we didn't do loops and functions. So let's edit the script one more time and create a function that will be called by a loop. Functions are defined the same way as variables, but in place of value, we place a do action. Let's output the value of $1, which is the first argument that the function receives, followed by the squared value of that number. Notice there is a $sign before the bracket with the multiplication. This is necessary to execute an operation in the middle of a string. Then let's do a simple for loop with the integer I going from 1 to 9 and have it call our function using the value of I. Now when I save it and run it, I get a cute multiplication table. When you consider that generated variables like this could be used to automate configuration and RouterOS has built-in script trigger mechanisms, the scheduler, the netwatch, and DHCP actions, then you realize that you could script almost any unique feature or router behavior that you need. Many people have written useful scripts for RouterOS, and if you search online, you will find countless forum articles and even entire GitHub repositories. To learn more about different scripting commands and operators, visit our help page. The link is in the description.